Okay, here we're going to do two quick examples of separable differential equations, all right? Our goal here is to separate these two things that seem to be mixed up and make them either as a product or as a quotient of a function with theta and a function with y in it. All right, so I'm looking at this and I'm thinking this looks kind of suspicious here. Secant is 1 over cosine. So 1 over cosine in the denominator, I can pop that up to the top. That will be diagonally opposite my theta here. So if I just bring the e to the y down, I'm really golden. That is the way to go. So this just becomes sine squared of theta over, multiplied with the cosine of theta. Again, secant is 1 over cosine, so it pops it up. And then down below will be e to the y, y, and then I'm thinking ahead here, e to the minus y when it goes down below, okay? Well, then I can write this as our separated expression. I can say that's sine squared of theta cosine squared d theta equals y e to the minus y and then dy. Well, I've separated them. I can put the integrals out in front and integrate. Well, if you go and think about this, this is integration with u substitution. This one looks like integration by parts. The quick u substitution here has got to be u is equal to sine of theta. So then du is equal to cosine of theta. I just want to find a little bit of the derivative in that second expression, which I've done. So then this becomes the integral of u squared du. And that is just going to be 1/3 u to the third, which then will give me 1/3 sine cubed of theta. Well, on this side, this is going to be by parts. If I use the Lie8 rule, it's pretty clear that I'm going to have, that's my algebra. So I say let u be equal to my y, and then du is equal to dy. That leaves the exponential part, so dv is equal to e to the minus y dy, and then I integrate up and I get v is equal to negative e to the minus y. So that means that this expression here, I'll just write it there, is going to be these guys, so that's minus y e to the minus y minus then the integral of these guys here, and that makes that plus e to the minus y with the y, just that with dy. Well, I can integrate this then, so this becomes minus y e to the minus y. When I integrate this, it just becomes minus e to the minus y. These guys are equal, and then I tack on a plus c. All right, well, if I wanted to get y by itself, that will be darn near impossible. I can't really do that. So if I wanted to get theta by itself, I guess I could say theta is equal to 3 times this, and then cube rooted, and then I would have to do the inverse sign of that. I don't know if that is necessary. Cube root, and that would be 3 times that whole mess right there. This guy down here, different. When you look at that, it's all about trying to separate this into be the product of two functions. I definitely would want to group the t's. So you might see the first instinct you'd have is to be something like do t and then 1 plus u, like that. If you do that, then you kind of look over here, and I think what jumps out at me is the 2's in both places. That looks highly suspicious. So if you think, oh yeah, I can factor that out, 1 plus u kind of does jump out at you. Well, now I've got identical things that I can factor out. So this just becomes 1 plus u times 2 plus t. And sure enough, of course, if I'd foiled that out, I would have gotten that up there. So if I say, well, that's du dt, then I can simply multiply both sides by dt and get rid of the u, and say 1 over 1 plus u, then du is equal to 2 plus t dt, and then I integrate both sides. This is our separation, and then I get the ln of 1 plus u equals 2t plus 1/2 t squared, and then I guess I'll do plus c on this side. So 1 plus u equals this raised to the e power, or e raised to that power, I should say, 2t plus 1/2 t squared, and then plus c. Well, that's really, I think you're just going to take and say that's the same as e to the 2t plus 1/2 t squared times e to the c. Well, e to the c is a constant, so I think pulling that out front makes sense. And then if we subtract 1, that'll be equal to u. So maybe that's the best way to write that answer. All right, there you go. Good luck.